All right. So this question is asking you to solve for t, correct? So the issue here is that it is a quadratic. So like literal equations, like d equals rt, stuff like that. You can solve for rate, solve for time, that kind of thing. And I can go through my procedures of order of operations and isolating variables and that kind of stuff because everything's to the first here, and every variable is showing up one time. Here, even if I had like r squared, I can still solve for r, right, by going through my traditional normal linear equation type procedures, order of operation stuff. But the moment that I get the same variable to show up a second time with a greater degree, that becomes an issue, and I can't go through our normal way of solving or isolating variables. But we do have techniques for solving and isolating variables using quadratic factoring techniques. Okay. Now, the one thing about this is to factor, I need to be equal to 0, right? So I'm going to get this thing equal to 0. So I have 1/2 g t squared plus v sub naught t minus h. Okay. Now, with that, the idea is, okay, can I think of two numbers that multiply together, give me h, and add to v sub naught? Well, I don't know what h is, so no. And I don't know, that even gets more compounded because I don't know what v sub naught is. So the product sum technique or the AC methods, that kind of stuff does not work here. So you have to turn to your default technique of factoring quadratics, which is the what? Quadratic formula, right? And the quadratic formula is always x equals the opposite of b plus or minus b squared minus 4ac all over 2a. Now, I said x because generally that's the variable being used in our quadratic. What is our variable being used in our quadratic here? T. Okay. Now, g and v are variables, but they are constants that we will know. So those things there are actually coefficients. Does that make sense? Okay. So when I talk about my a term here, a is 1/2 g. When I talk about b, it's v sub naught. And when I talk about c, it's my negative h. Does that make sense? Okay. So opposite of b would be negative v sub naught plus or minus b squared. So in order to type this one in on your WebAssign, there's a box on your toolbox. There's a box there, and then it's got that there. Does that make sense? Okay. You need to pick that one because it's got the ability for you to type in a 2 and a 0 stacked on top of each other. If it's just one like this, you can't use that one. Which one? Did it work? I don't think that one's going to work because... Okay. If it works for it, I will just be careful because... Yes. Okay. All right. So then I'll go minus 4a. A was 1/2 g. And c is then negative h, right? All over 2a. So 1/2 g. Just simplifying some of that stuff. So I got the opposite of v sub naught plus or minus v sub naught squared. Okay, so now a negative times a positive times a negative is going to be a positive. 4 times 1/2 is 2. So we get 2g times my h. And then all the bottom, 2 times 1/2 is 1. So we got 1g. And that's my t value. Does that make sense? Okay. One thing I talked with the last class about is that tool tab that they give you. It takes some time to get used to that. It takes some time to get accustomed to what those functions are doing for us, and it also takes time to realize, okay, I can use this button. Okay, maybe the one with the box on the top, the superscript and the subscript, or maybe I can, like you said, you took the subscript and you squared the subscript one. You just got to figure out which ones are they looking for, that kind of thing. And there should be like a syntax, like help thing there, I think. Am I wrong? Is there a button there to show you syntax of what you've typed in right or wrong? It might show up actually when you actually typed it in wrong. It might be part of the feedback. If I type that in and I get it wrong, okay, look at the way this is written. That's not the right way we wrote it, right? Okay, they use the associative property, the commutative property, and that kind of stuff a lot when they give you feedback. Okay, just be on the lookout for that. I think even on question 7, which we did on, what did we do, 7 on Friday or Thursday? Maybe it was Friday. And we talked about if I type it in wrong and it gives me this feedback that that's the right answer before I go to like a similar exercise or something, I might not recognize that, okay, that is really the exact same thing I had done myself by hand, but maybe I missed a sign or something like that. Does that make sense? So being able to transform an expression using our algebra skills, commutative property, associative property, that kind of stuff, is going to assist you in checking your work against the feedback that they give you. So there should be. So the question is, you guys are gonna, because this is the side of things that I see. So I don't see it as a student, but there is. So if I go to my settings, right now you got 7 submissions. Okay, so I guess what that means is you get it wrong. So the similar exercise phrase is maybe incorrect. You get 7 submissions for that question, and it won't regenerate another. Right. So you get work on that one 7 times, but it won't regenerate one after that. Does that make sense? Yeah. Okay. So does that help with that question? Okay. So let's go. You said 17, 19. Okay, so this is my A term. This is my B term. And this is my C term, right? Now, when I take my B term, okay, so it might actually make sense just to save ourselves issues with that negative. Can I do this? A x squared plus, can I rewrite this as negative 2a minus 1 times x plus now a plus 1? Is that okay? Huh? Yeah, because I'm subtracting that whole quantity. No, because that would be like taking, so that'd be like if I had like 5 here as 5x, then that makes sense, because that thing right there, when I know what A is, that becomes a quantity. So I don't. So now if I go my variable x is equal to the opposite of b, okay? So I'm just going to write as the opposite of negative 2a minus 1. That's b, right? That's the opposite of b. Plus or minus. Now b squared, so negative 2a minus 1 squared, minus 4a is a, and c is a plus 1, right? All over then 2a. All right? So we need to get that. Okay? If we can't get that, then the simplification that we're going to do here in a moment is pointless. Okay? So now I'm just going to work with my negatives out here. So negative, or the opposite of negative 2a is 2a. The opposite of negative 1 is positive 1, right? Plus or minus. Okay, now when I square this, 4a squared, multiply these two together, so that gives me 2a, right? Double it, gives me 4a. Negative 1 squared is plus 1. So there's one question you got to ask yourself. Did you, when you squared that term, did you remember you're going to get the O and I to give you 4a? Okay. Then we're going to have, so what, negative 4a times a is negative 4a squared. And then negative 4a times 1 is negative 4a, right? So the 4a squared cancel, the 4a and negative 4a cancel, and I'm now left with 2a plus 1, plus or minus root 1 all over 2a. Yes? Say again? So what I did is, because of my associative property, I took those two together first. So I'm going to rewrite that as negative 4a. So kind of like that. And then you got to distribute to the a and then to the 1. All right, so what is the square root of 1? 1. So I got 2a plus 1 plus or minus 1 all over 2a. All right, so two answers that we get. If I go with the 2a plus 1 plus 1, 2a plus 1 plus 1 all over 2a, that gives me 2a plus 2 over 2a. What do they all have in common? They all have a 2 in them, so I can rewrite that as a plus 1 over a, right? That's one solution. If I look at the negative portion, so 2a plus 1 minus 1 all over 2a, the plus 1 minus 1, additive inverses, they go away. So it leaves me 2a over 2a, which is just what? Just 1. So there's my two solutions, a plus 1 over a and 1. And then the idea is, okay, well, if I wanted to, so why go through this? Let's say for some reason I've got this formula, maybe in a computer program, trying to do something for me in my computer program, and I needed to find the zeros of this quadratic. Instead of asking it to like factor using our other techniques or even factor using quadratic formula, what we would do, I would not program my computer with this here. Because how many times do I have my computer referencing what A is, substituting, evaluating, that kind of thing? I got it happening a lot, right? Figure out what A is. Well, plug in A there, 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 right? It's got to evaluate and do all that math. And when we do that, it takes up RAM, it takes up, which is ultimately time and money as well. So there's a lot of resources that get consumed by not having a very concise math representation when I'm coding this. What would be nice is to go through the math prior and say, okay, well, the zeros are going to be these two things. How many times do I have to substitute to find the zeros here now with A? Just 2 times, right? That makes that that program for my computer much faster. Okay. So here's the thing. Did we see any questions like that in our home or in our notes during the course of last week? No. Okay. There's a question. What about the sailboat question, or the one boat goes eastbound, one goes southbound? Okay, so let's talk about that one as well. So we didn't see questions like that. We saw general concept questions. Okay, and the idea, guys, is when I give homework, I don't think, and this is maybe contrast to what you want to happen, but I don't think homework should be something that you can always just kind of breeze through. Okay? And my thought on that, my logic behind that is, if you just breeze through, the homework is supposed to challenge you, it's supposed to motivate you, it's supposed to get you beyond the current point that you are at, okay, in terms of your learning. And if we don't challenge you, and it's just something that you could do without me giving you notes or something like that, I don't think we gain anything from it. Does that make sense? So you're going to run into difficulties. I guarantee it. Okay, my homeworks are designed that way. It's going to be frustrating at times. Guarantee it. They're designed to be that way. Okay. Now, if that's the case, so my thought is, if I'm going to make the homework like that, you not only get the, how can I phrase this, the frustration, okay, that comes with not being able to do a question or a struggle. And I like what you guys are doing. This is what I wanted. I wanted you to come to class, and I wanted you to ask questions. I wanted you to say, I did this, and I did this, but then I got stuck here, or something like that, okay? It makes you think about your process. It makes you think about, am I a learner that when something becomes difficult that I just stop and wait for somebody to get me unstuck, or do I dig a little bit, okay? Do a little bit of research on my own to get through those. And I think that's something, as you guys get into higher level courses all across the spectrum of your curriculum, math, science, English, whatever, you're going to be in situations where it's required of you to do that external digging, okay, the extra legwork outside of class to make something make sense, okay? And I would hate for you guys to get to a college campus and that be the first time you experience that, because you experienced that for one semester and it's completely foreign to you. That might be the last semester you experience it, because you might drop out because it was difficult, right? Okay. One of my favorite phrases, I got a couple of them, but nothing bad has ever come from hard work. Okay. And the other one is that comfort is the enemy of progress. Comfort is the enemy of progress. If you're comfortable where you're at, you're not going to get anywhere else. Does that make sense? You're not going to achieve at a higher level if we're just happy with the way things are. Okay. So my homeworks are going to challenge you. I think you should learn something from them. Again, it's not always like, I'm going to go over the easiest questions for notes and then just blow your minds away with the homework. There will be assignments that you can breeze through, but they're the ones that provide you difficulty. There's a purpose for them. Okay. All right. So I don't know what question this was. But it says 2 fishing boats depart. It's 12A. 2 fishing boats depart a harbor at the same time, one traveling east, the other south. Right there, key geometric concept. One's going east, one's going south. What kind of representation do we have here then? We have a right angle. Okay, and that's huge for this question and how we're going to relate things. So we got a right angle right there. It says then, the eastbound boat travels at a speed 7 miles per hour faster than the southbound boat. Okay. Gives me 2 rates. Eastbound boat, southbound boat. But they're not numerical. Okay, but it says the eastbound boat travels 7 miles faster than the southbound. Do you know how fast the southbound is going? No. So when you have unknown things that are related to one another, you let the simplest thing, or the one you know the least amount about, be your variable. Does that make sense? Okay, so these two rates that they give us are related to one another because of the description, and I know the least amount about my southbound, so let that be X. My eastbound then is X plus 7. So it was 7 miles per hour faster. In the whole grand scheme of things, you can mess those two up in this problem and get it right. Okay. However, if they ask you, let me phrase this. You could get the right math, but in the way you analyze the solutions and then decide, okay, which one of those is the southbound, which one of those is the eastbound, that might provide an issue. Does that kind of make sense? It's important to make sure that we get our variables in the right positions so we can answer the questions that are asked at the end. Okay. Now, what were those? X plus 7 and X. Are those distances or were those rates? Those were rates. It says one was traveling 7 miles per hour faster than the other. So those are rates. Now, after 7 hours, these two boats are how far apart from one another? 91 miles. Okay, is that a distance or a rate? That's a distance. Okay, so we can't compare these things or relate them inside an equation or an overall governing concept because they're not like things. Does that make sense? So you either need to change the rates into a distance or a distance into a rate. And we'll do it both ways and show you the contrast. But what would you rather do? Would you rather change two things or would you rather change one thing? Change one thing. So let's change the distance into a rate. And we know, so this is something that happens all the time in this class. Do you guys remember the first time that you came in contact with this formula? Do you know what grade that was? It was the 5th or 6th grade. Okay? We're going to use that thing a lot. Okay? So when I have a distance, that's equal to rate times time. So if I want to change that distance into a rate, okay, it's distance divided by time, right? Okay. So my rate then, they said my distance is 91 miles, and we were looking at this for 7 hours, right? So what's 91 divided by 7? 13. So 13 is now my rate. Is that okay? All right. Yeah, because after 7 hours we have 9. So that's, are you saying why did I divide 91 by 7? Because the eastbound travels speed 7 miles faster. So now, what is the number one geometric concept that we learned in like the 4th grade that relates these three rates now? A squared plus B squared equals C squared. So A is X, so I'll square that. B is X plus 7. And then C is 13. So what does X plus 7 squared yield? Good. X squared plus 14X plus 49. Number one error? Forget the O and I. So it equals 169. I'll combine like terms. 2X squared plus 14X. Oh, yeah. Minus 120 equals 0. Okay, so I factor out the 2. I think there's some logic here to talk about, some algebraic principles that we need to remind ourselves of. There are times where that 2 just disappears in our algebra when we factor, and there are times that it has to stay. Why here can it disappear? Okay, so when I have 2 times that set of parentheses, that's 2 times an object, right? So let's just call that object R. Well, let's call it P. Okay. So I really have on the left-hand side 2P, right? Equals 0. Well, how do I solve for P? I can divide by 2, right? Okay. So I'm going to divide both sides by 2, and that's where, because I'm dividing the left-hand side by it and the right-hand side, I'm actually doing the division here, but 0 divided by 2 is always 0. Okay? So that's something to keep in mind as we do work. If I were just to give you this, and this is what Anthony was saying, if I just give you 2x squared plus 14x minus 120, and I ask you to factor that, does the 2 disappear? No, because there's no 0 on the other, so it's not an equation, right? So when I rewrite an expression, the rewrite has to be the exact same thing as what I started with, just in a different format. Is that okay with everybody? Okay, yeah, so if I kept the 2, I could use the quadratic formula, and the only thing that's going to happen there is that all my constants then in my quadratic formula will be twice as big, so the math is going to be a little bit more, mental math may be a little bit more difficult. Or the reason I factor the 2 out here, what are 2 numbers that multiply together gave me negative 60 and have to give me 7? 12 and 5, so negative 5 and positive 12. And by doing that, I recognize that I can circumvent the quadratic formula. I can use, I think, a technique that's a little bit quicker. So now what are your 2 solutions? X equals 5 and x equals negative 12, right? Now, what do those stand for? What was x? X was a rate. X was a rate. There's a southbound rate, right? Can it be negative? No. So it's got to be 5, right? Okay. Now, that's by changing everything to a rate. You don't have to do it that way. We can come to the side here. Now, this is going to be kind of a quick explanation, but we're going to run through the problem the same exact problem, but use a different relationship. All right, so here's my right triangle, right? We had x as a rate, x plus 7 as a rate, 91 as a distance, right? Let's change them all into distances. Distance equals rate times time, right? This was a rate, and to get this 91 miles between the 2 boats, they traveled for 7 hours. So time times a rate, shouldn't that now be converted into a distance? 7x is now the distance. Can I do the same thing here? Okay, so now I've got 7x squared plus 7 times x plus 7 squared equals 91 squared, right? Yep. So 49x squared. Okay, so it's going to be 7x squared, so it'll be eventually, come on, delete. 49x squared. Okay. I think it's, what's 40? It says 686, I think. So 49 times 7, 343. 343 times 2, then 686. So I have 686 x's plus then 49 squared. Is that 2? Oh, gotta do it over here. No, I got 49 squared. 2401. Because I'm taking this. So does everybody see? I'm doing this. I'm doing these 2 things at the same time. But this is 7x plus 49 squared. So I was doing the 49 squared. So it's 2401. 82, 81. Okay. So that's 98x squared plus 686x's minus, what is it? Let's go 82, 81 minus 2401, 5880 equals 0. What do you think all of those are divisible by? 2, 98. I divide that by 98, gives me x squared. Divide that by 98, what do you think that gives me? Saw 7 in the last, didn't we? Divide that by 98, 60. Gets down to the same thing, right? Okay. Which was easier, though, to change everything to a distance and get these numbers, or change everything to a rate and get the other ones? Yeah, go to the rates. Now, did you know that at the onset? Probably not. And a lot of times you really don't maybe know the payoff. But if we go by that first question, would you rather change 2 rates to a distance or 1 distance to a rate, and you be efficient there, it makes the rest of the problem efficient. Okay, so those are always things to think about. So we got here 51. All right, so there's a question on there. Now you guys said, some of you said you figured it out. Yeah, like a baseball thrown or something like that. Anthony? Okay. Okay.
10, right?
10 squared.
10. Oh, that's what I did wrong. Okay. Is it the 5-part one?
Yeah, like when the ball hits the ground and that kind of stuff. They're good. So the comment I heard just a moment ago is that there was a video on that one. Okay. Now some of these have videos attached directly to them, right? Okay, but let's say there wasn't a video attached to it. Can I still do some digging and researching, maybe via Google or YouTube, that talks about that scenario? Okay. I don't know how many times, guys, in a math class that I got stuck on something, and I would just go to YouTube and I would type some resemblance of that question in there, or some resemblance of what we're talking about in class, and see what populates. And I might search. Sometimes I search and find it in one video. Sometimes I would search for 3, 4, 5 hours before I found what I was looking for. Okay. I'm not saying that's what you need to do. Search for 3 or 4 or 5 hours over something in this class, but there are a lot of things out there to help you. Okay. Now the question, says something. Does anybody know what question number it was? Okay. So a ball is thrown straight upward, initial rate or initial speed of v sub naught, 80 feet per second. So use this formula, but I want to make sure that we understand really what is going on with the physics. So we're not going to get through all of this. We probably won't even get to start talking about the example yet. But this is what's going on with certain things in this section compared to what you see in maybe a physics class. So when you throw an object or launch an object, fire an object, whatever you want to say, kick it, whatever, the path that ball or object takes, okay, is a parabola, okay? And so if I throw this marker, okay, and I freeze time right here, okay, so I've let go of my hip, and it goes, and I freeze it, and the marker's right here in the air, okay? We can talk about that marker's position several ways. One of them is to talk about the horizontal displacement, essentially the horizontal change from where it started to where it is now, in the vertical displacement, or that vertical change. Does that make sense? Okay. That's what you're going to talk about in physics. Okay. And you guys are going to create quadratics in physics about those horizontal and vertical displacements. That is the image happening on the left here. If I fire this object and I pause it, every single ordered pair on that dotted curve right now is an X distance that the ball has moved, comma, a Y distance that the ball has moved. So that's a horizontal and vertical displacement of that object. It's actually moving through two-dimensional space. Does that make sense? Okay. So we can do that. That's great. That's awesome. We talked about last week, I think, that you play that tank game where you have two tanks on a side of a screen and you're shooting, you're changing the turret's angle and you're shooting the tanks. You guys ever play that game before? That's what's going on behind the scenes here. Okay, it's this math. If you ever watch like a baseball game and they show a guy hit a home run and then they show like the curve of the ball and they project the total distance of that home run. The math that's going on behind the scenes is this right here. Okay, they talk about launch angle, they talk about exit velocity, that type of thing, and they project this parabola. Very easy concept that we're talking about here. Okay, now what we're actually talking about in this class, look at that example. It says in that example, really what we're doing, we're throwing the ball straight up. This is throwing the ball at like a 70-degree angle, right? So it's winding up and like letting go out in front of my head. Okay. But this, I'm winding up and I'm throwing the ball straight up in the air, or I'm taking a gun and I'm shooting a bullet straight up in the air, okay? And there are no other forces at play here other than gravity, so what goes up must come down. And because no other forces are at play, it's going to come straight back down. So if I fire this, it goes straight up and straight back down, right? Okay, now that's the vertical and horizontal displacement. We see a displacement vertically. As that ball moves, it's being displaced from its original position, right? But is it moving left or right at all? No. Okay, so we don't see a parabola when we throw something straight up and down, right? Okay, however, excuse me, if I come over here, look what's happening over here. When I fire this, okay, this over here is a graph. The x-axis is time that the ball is in the air, and the y-axis is the height of the ball. Okay? Well, when I throw a ball straight up in the air, and it comes straight back down, let's pause it right there. This is saying at 3.04 seconds, we've reached a height of about 45 meters. Does that make sense? So that point right there, that ordered pair, would be 3.04, comma 45. Okay? Every single time you take an object and you drop it or you throw it straight up in the air, and then you record the height of that object and the time that object reached that height as a bunch of ordered pairs, and you assemble them in an XY plane, you will always get that parabola in red. Okay? And that's what that negative 16t squared plus v sub naught t plus the initial height is going to generate every single time. Does that make sense? So what I want, before we get that example, we'll start that example tomorrow. The questions that we do in class, when they have a projectile, we are not talking about the horizontal and vertical displacements of that projectile, the left and right, up and down movements of it. We are talking about the height of that object being measured at a particular time and graph. Basically, all the points on that red curve right now are t, comma, height, or time, comma, height, okay, of that object's in the air. Is that okay with everyone? So we understand that concept, that background. Tomorrow, we can actually dig into actually doing that problem and talking about the key points when they say, when does the ball return to the ground? There's no numbers there, but they are telling me that the height is 0 when it comes back to the ground. So we'll talk about those key phrases and terminology in that question that kind of point towards a numerical value for the equation. Okay. I will extend that homework and web assign through tomorrow evening.